Hi, today's lesson is on factoring. We've been solving lots of quadratic functions or quadratic equations, and again, quadratic ones are equations that have x's that are squared. And so we've learned how to solve by using the square root method, and we've learned how to solve or reviewed how to solve using the quadratic formula. And today what we're going to do is we are going to review how to factor so that we can solve by factoring. So again, the first step in factoring is to look for a GCF. And again, a GCF stands for the greatest common factor. And again, the greatest common factor is the number or variable that each of the terms has in common. So if you look at 7x squared and 49, hopefully you recognize that both of them have a factor of 7. And when we worked on greatest common factor or factoring, you pulled out that GCF and then you asked yourself, well, what would I have to distribute to get that answer back? So in order to get 7x squared, I would have had to distribute 7 to x squared. And in order to get a 49, I would have had to distribute a 7 times a 7. And so factoring, if you remember from our previous chapters and last year, is sort of undistributing. And so this would be my factored answer. I looked for the GCF. So your first step, again, is the same thing. So if I look at the second example I have here, if I look at just the numbers 2 and 5, 2 and 5 have no factors in common, but x squared and x each have an x in common. So I'm going to factor out an x. So that means in order to get this value back, I would have had to distribute to 2x. Because if I distribute an x to 2x, that would give me 2x squared. Plus, always try to keep that sign the same as long as you pulled out a positive number here. And in order to get a 5x, you'd have to distribute 2x to just a positive 5. So factoring is undistributing, and so this would be my final factored answer. Okay, the next type of factoring that we're going to look at is same idea, but notice that now if we try to look for our greatest common factor in this first example, again, it's still a quadratic expression because there's an x squared, but there's no greatest common factor between the three terms. So then we're going to work on sort of undistributing like you learned last year, factoring like you learned last year, where if it wasn't just a distributing one with a single number, it's going to be a distributing problem, possibly, with two quantities. And so the way that we figured this out is some of you were able to just see, well, in order to get an x squared, I needed to do x times an x, because x times x would give me x squared. And then we had to figure out the rest. And so what we said was, if you looked at the negative 11, this was what we called the c value, so you looked at this negative 11, and really there's a 1 here. And so what we said is you should look at what a times c equals. So 1 times negative 11 is still negative 11. And then you want to figure out what do the factors add to, and we need it to add to that b value, add to the b value, which is 10. So factors of negative 11 would be negative 1 times 11, or positive 1 times negative 11. And which one of these adds to a positive 10? Well, the first one. So we know that there would be x minus 1 and an x plus, because it's a positive 11, positive 11. Now, we have factored this. This would be my final answer, but your way of checking would be to distribute. So how do we distribute? We would do x times x, that's x squared. We would do x times 11, so plus 11x. We would do a negative 1 times an x, so minus 1x. And we would do a negative 1 times an 11. If we combined our like terms, we have x squared plus 10x minus 11. So we know that we did our answer correctly when we found out our factors were just x minus 1 and x plus 11. So that would be my factored answer. So sometimes they're easy and you might not need to write them out, but sometimes you will. So for example, my second example, I first look and realize there's no greatest common factor between all three of them. It has to be between all three. So then I'm going to say, okay, A is 1. So A times C is 98. And B has to add to B is 21. So now I'm going to write out all the factors that multiply to 98. So 1 times 98. 2 times 49. Now, might need to think about this a little bit more, but 98 does not divide by 3. 98 does not divide by 4 evenly. Won't divide by 5 because it's not ending in 5. Doesn't divide by 6. 98 does divide by 7. 7 and 14 multiplied together. And what you want to do is you keep wanting to divide, so 98 divided by 8, 98 divided by 9, 98 divided by 10, 98 divided by 11, 98 divided by 12, 98 divided by 13. And you find out that the only other number that's going to happen is going to be the 14, and we already have 14 listed. So these are my three factor combinations that multiply to 98. And only one of them adds to 21. 7 and 14 add to 21. So since they're both positive, that would be x plus 7 and x plus 14. So this would be my final factored answer. And again, you could check it, and you should. Double check that if you distribute x times x is x squared. X times 14 would be plus 14x. 7 times x would be plus 7x. And 7 times 14 would be plus 98. Combine my like terms, x squared plus 21x plus 98. And I realize that yes, this is definitely my final factored answer. Okay, our next example is really the same type of thing. We're still going to be trying factoring, and first you look for a greatest common factor, and I don't notice one. So then if you don't notice the greatest common factor, you look at, again, your A term. So A is 3, and C is 21, so you do A times C, and 3 times 21 is 63, and then you look at the B term, B is 16. And so if we're trying to factor, we want to look for things that multiply to 63. So 1 times 63. If you try to do 2 times 63 doesn't work. If you try to do 3 times 63, well, we already saw that that was 21. If you try to divide by 4, that doesn't work. If you try to divide by 5, by 6, by 7, you recognize that 7 is your next answer. And so now you have to look for which ones add to 16. And 7 times 9 is 16. So this is a little bit different, again, because there's a number out front. But we're going to start off sort of using the same method as before. So x plus 7 and x plus 9. Now you should recognize that if you distribute, that's not going to get you back to your original answer. So what we have to do next is what we call sort of a bottoms-up method, and it's a mathematician's way of sort of, instead of guessing and checking, making it a process. So what we do is, after we figured out our factors, we're going to divide each of those by A. So we're going to divide each of these by 3, because that was A. And then we're going to simplify. So this would be x plus, well, this first one doesn't simplify. And this would be x plus 3. And our last step to get to our final answer is we call it bottoms up. So since you have still a 3 as a denominator, this would be 3x plus 7 times x plus 3. Now you could have guessed and checked all of this, and that's completely fine. But what we're trying to teach you with this bottoms up method is a quicker way of finding the factors. And if you distribute it out, you'll get 3x squared, so you know you're working in the right spot, and you would double check and you'd still get your 16x plus your 21. So if I double check this next one, I look for GCF. I see no GCFs, so I will do A times C. So 4 times 9 is 36. B is 12. So I'm going to write out all the factors of 36. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. And so we recognize that this is my one that adds to 12. So again, x plus 6, x plus 6. This wouldn't be my final answer because it doesn't distribute to the right thing. So we said take your a and divide by both of those. So if I take my a and divide by both of those, the next step would be to simplify or reduce. So this would be x plus 3 halves. And this would be, again, x plus 3 halves. And since we can't simplify any farther, then you bring that bottoms up. So you take your denominator and you bring it up front. So 2x plus 3 and 2x plus 3. So this would be my final factored answer. So that was just a brief review on factoring. Please go back and watch again. If you have any questions, please ask in class.